All right, welcome back. We are doing a new chapter, and this chapter, I wanted to tell you what the chapter is called. This chapter is called Transformations and Symmetry. Transformations and Symmetry. And so, transformations, you'll learn what that is today. Symmetry, I think you guys know what symmetry is. And then, just in terms of the math sense of what those things are. So, give me one second. Okay, so transformation just means how something, and you'll hear me say words today like slide, flip, spin, bigger, smaller. You'll hear me say certain words. Um, so so pay attention to those words and see which words already make sense to you. So here's the jump start. It says, given the preimage point A, so preimage, get used to that word at 5, 2, as shown in the diagram. Find the location of the image point if A is, and then all of these things. So the first one is reflected over the x-axis. So if it's reflected across the x-axis, all I'm going to do is I'm going to count towards the x-axis. There's 2, so towards it would be this. And then, so this would be reflected across the x-axis. So I'm going to call that A. And I'm going to erase my little helper tool here. My line right there. Okay, so that's A. And you know that it's reflected across the x-axis because it's the same distance away from the x-axis. Okay, then B says reflected over the y-axis. So you're going to do the same thing. So it should be right here. And let me change colors. B goes here. Okay. And then it says 180 clockwise around the origin, counterclockwise. So it's going to turn in this direction with 0, 0 being the center. So where is it going to end up? Okay. So the way I kind of imagine it is I kind of draw this line like this, and I kind of draw like the other side of that, like this, I think. And then that's where I end up, right? Because this is 180 degrees. And so now it's 180 degrees around this origin right here. Okay, so that's C. And I'm going to erase my little helper again. D says rotated clockwise. So clockwise means it's going to go this way. Oops, sorry, I wanted to change colors. Clockwise means it goes this way, like the way the clock's hands go, 90 degrees. So I still do that thing where I connect the dot from the point to the origin, but now 90 degrees looks like this. It's kind of like, see how that's 90 degrees right there? So that's this point right here. And so I have a little helper, and I use this like rectangle. So I'm going to highlight my little triangle. Sorry, not rectangle, triangle. You see how I have a little triangle right there? I use that same triangle this way. It's almost like I push it up against there. It's kind of like, I don't know, for me, I kind of count slope. You see how I count the slope right here? 2 and 5, but because it's 90 degrees, I switch them. So this goes 5 and this goes 2. Does that make sense? So that's my little helper. And then the last one, it says translates 2 units left and 3 units up. So 2 units left and 3 units up. So it's almost like, I don't know. Whenever it moves in directions like this, like 2 units left, 3 units up, I think about Pac-Man. Because Pac-Man before, I don't know if you guys know this, but before they got all crazy with their technology and games, it can only move in the X direction or the Y direction. And then came like Super Mario Brothers, and then they could move in like a diagonal direction. All right, so there you go. So our focus today is identify features of translations. I'm just going to write the word move. Rotation means to spin or turn, and reflections means to flip. Okay, so what tools and strategies do I use when I translate a figure, rotate a figure, reflect a figure? I showed you some of mine. Okay, what do these tools and strategies reveal about transformations? And although each of these transformations move figures in different ways, what do they all have in common? Okay, so animated film and cartoons are now usually produced using computer technology rather than hand-drawn images used in the past. So computer animation requires both artistic talent and mathematical knowledge. Sometimes animators want to move an image around the computer screen. This is kind of what I was telling you about Pac-Man versus Mario Brothers, right? Um, so an image around the computer screen without distorting the size and shape of the image in any way. So imagine when Mario would like jump, he got skinnier or taller or fatter or rounder. I don't know, whatever. So they don't want to distort him. So, and imagine if you got distorted when did any of these things, rotate, move, anything. This is done in using geometric transformations such as transformations, slide or translation slides, reflections, flips, and rotations, turns, or perhaps some combination of these three. These transformations need to be precisely defined so there's no doubt about where the final image will end up on the screen. Today you will be animating a lizard shown on your handout by transforming it in various ways. If you want a bigger version of the handout, it's right here. If you scooch your paper over and look up, it's kind of like where the your exit ticket normally is. So here's a bigger version of it. Okay, so I'm not going to use that bigger version, so you guys can use that. So the original lizard was created by plotting the following anchor points on the coordinate grid and then letting a computer program draw the lizard. The anchor points are always listed in this order: tip of his nose, center of front foot, left front foot, belly, center of left rear foot, point of tail, center of right foot, back, center of right front foot. And then they give you all these anchor points. So these anchor points are right here on the lizard. So if you look at the lizard, there's the anchor points, those black little dots. Okay. Okay. So then it says, each statement below describes the transformation of the original lizard. Do the following for each of the transformations. Plot the anchor points for the lizard in its new location. Connect the pre-image and image anchor points with the line segments or circular arcs, whichever best illustrates the relationship between them. Translate the original lizard so here's number one. Translate the original lizard so that the point on the tip of its nose is located at 2420, making the lizard to appear to be sunbathing on the rock. All right, so I'm just going to say this. It is best for this one if you print this little guy out. If not, don't worry, just no. Okay, so they want me to translate the lizard so that his nose is now at 2420. So currently, his nose is right here. I'm going to give him a pink nose. He's right there. But now they want him to go here. Okay. So because they want me to move him there, that means everybody moves. He's not just, I mean, he is a lizard, right? So we could just chop off his nose and put his nose on the rock, but that's not what we're doing. We're going to move all his parts. And so the way I think about when I translate stuff, I don't think about the whole thing. I just think about certain points moving and the rest of it just coming along with it. So the way I think about this is I'm just going to draw, I'm going to count how many spaces it goes up here. And how much it moves over this way. And then that means that's going to be the direction for every other anchor point. Does that make sense? So here he's moving up 8. And then here he's moving up 5, 8, plus 4, 12. Okay. So every single one of these, they're just going to move up 8, right 12. And then I'm not going to draw the lizard, but you can kind of see how his little body's going to be. Okay. All right. So I'm going to start, and I'm going to use different points so you guys can all see how this point. So here's his hand. He's going to go up 8 and then right 12. So 5, 10, 11, 12. So there's his little nose. There's his little hand. Okay. The next point I'm going to choose is this point right here, his belly. And then again, he's going to go up 8. If you don't know what I'm doing, I'm just counting this way, 8. And then I'm moving over 12. So here's 3, 8, and 12. So that's where his belly would be right there. Okay. I'm going to erase my little helper because that way you guys can, it's not going to get a mess. My next little guy is going to be this green. So this is his foot. So again, he's going to go 8. So here's 5, 8, and then he's going to go 12. So this is where I am when I go up 8. Now I'm going to scoot over 12. So that's 1. Here's 6. Here's 11. Here's 12. So he really is sunbathing on that rock right there. The next little point I'll use is this guy right here, and it's his foot. So I'm going to go up 8. So here's 2, 5, 8. So here's where I am. And then I'm going to scoot over 12. So 5, 10, 11, 12. So that's his foot. I'm going to keep moving on. Here's his end of his tail is right there. So I'm going to go up 8 again. Here's 1, 6, 7, 8. And I'm going to do 12. So here's 6 and then 12. And then last but not least, I'm going to use this last point, which I don't have a color. I'm just going to use my crayon pen. I think this is my crayon pen. So I'm going to go up 8. So there's 4. Here's 8. This is where I am right now. And then I need to move over 12. So there's 6 and there's 6. So can you see, I know it's just a bunch of dots, but can you kind of see where the lizard is? I'll try to draw his head. How about that? If I can draw his little head. So his little head goes up here. And then it goes like this. See, do you see his head? Miss Johnson is drawing heads for you guys. Oh my gosh, what happened? And it goes like this, kind of. See his little head? Everybody see his head? You guys are like Miss Johnson. There's his little neck. You guys all see it? Okay, that's the most that I'm going to give you. You guys are like Miss Johnson. You got a headless lizard. I mean, a bodiless lizard right there. But that's like okay. Does everybody see how the whole lizard moved with him? Not just, his nose. Okay, so when we're moving things, we're just going to make sure that when we move them, it moves. So if my lizard, when I moved him, came out to be like, I don't know, he was like this. And then his little tail. Here's his hand. Here's his foot. Here's his other foot. This. And you'd be like, Miss Johnson, what happened to your lizard? Well, okay, let's pretend that the lizard got really, really skinny. That doesn't happen when you move, right? So when you move, you don't get skinnier like instantly, right? Yes, if you exercise, you will eventually lose weight. I get it, but my point is that. Okay, next one. Rotate the lizard 90 degrees. Okay, oops. Rotate the lizard 90 degrees so that around 0.127, so it looks like he's diving into the pool of mud. Okay. So the first thing I'm going to do is I'm going to look at my lizard, and there's that 0.127. You guys all see my point right here, 12.7? That's the point we're rotating around. Okay. Oh, I forgot. It said to connect my points. Oish, I should have done that. Sorry, I forgot to do this. Do you remember here it said connect the pre-image and the anchor points? So let me connect these points. I wonder, let's see. shapes. Let's try to draw shape. Okay, so I'm going to try to connect these with points and see what happens. Wait, where'd it go? Shapes. This. Oh, it's like highlighted. That's not what I wanted. Hold on a second. Give me a second. Okay, so what I did is I had to switch to this so I can actually draw. So what they wanted you to do was they wanted you to connect your image to your pre-image. So I connected this, and then I'm gonna grab these, and they should all be the same length and the same kind of like, oh, see, it doesn't ever, sorry, this is snapping and it's not getting to where I want it to. Okay, I might skip some. All right, I might skip a lot. Let's see, can I do this? Yeah, it's not letting me crop any. Let's see if I can do one more. Let's see. Okay, I guess I just have to do it like that. See how I connected his hand to his hand? Okay, then I'm just going to copy this again. And then I'm going to take this guy and connect his hand. And then that one is blue. So I want to go after this one right there. Yeah, they look pretty good. And you should see a pattern happening, and you should be doing this on your own. And just trying to grab them and make them really obvious. Right there. And right. Yeah, that one's a little bit, it's not, oh, there it goes. It's a little bit, they're a little bit cranky. But if I continue doing it, do you see how all of these lines, do you see the relationship of all of these lines right here? That's what they're asking you to do, is just connect the dots. And you should see that these lines have like a really neat thing going on. All right, let's continue. Okay, so we're going to be rotating him around this point. So if you can imagine a circle, and then it's rotating it around like this. So it looks like he's about to, I don't know, dive into that mud. So one way to do it is making circles. Miss Johnson's not very good at making circles. So I'll show you my little way. So again, I connect these dots here. And then I count how much it is, and I just make 90-degree angles with them. Does that make sense? So here we got 2, 5. So here we're going to go 2, 5, dot. So that's where his nose is. Okay. And then we're going to continue. We're going to go this one here. Right. And I'm going to try to make a perpendicular line. And I told you before that I kind of use this like this triangle here. Do you see that triangle? So this triangle is right 3, up 5. So now I'm going to go over 5, up 3. So over 5, up 3. You guys all see how I did that? Over 5, up 3. And do you see my little triangle there? See how it's the same? Is that over 5? 1, 2, 3, 4, 5, up 3. Yeah, that looks right. And then you should see this 90-degree angle. Do you see that 90-degree angle? So that's my new point. Okay. And I'm going to continue doing this. Right. And you can kind of see like the 90 degrees forming. So I'm going to erase my little helper lines because you don't actually want to busy your graph with that, right? So that one's blue. Then the next one, this one's going to be pink here. And he's like this. So what is that? 5 and 5. So that means it goes a 5 and 5. Does everybody see that? So those 3 points are right there. You should see the 90-degree angle that I just drew. That's a 90-degree angle. So then I'm going to erase my helper lines. And then I'm going to continue. Here's this green point here, which looks like this. And then I count, right? Down 3, left 8. So I'm going to go this way 3 and then up 8. See those two triangles? I know they don't look the same, but they are. It's just I can't draw them congruently. Does that make sense? Is everybody okay with this so far? Did I count wrong? 3, 4. Oh, because it's not 8, it's 7. Sorry, guys. That's 7. Does everybody see how that's like those two triangles are the same? So again, I'm just going to erase my little marks again. And then I'm just going to continue all the way through. So here I have this blue guy here. Let's see, this goes down 3, 6. This is 6, and this is 8. So now I'm going to go 8 this way. 1, 2, 3, 4, 5, 6, 7, 8. And then up 6. 3, 6. Is that right? No, that's wrong. I should have gone 6. I'm sorry. 1, 2. I should have gone 6 this way and then 8 this way. So this side should have been a 6. And then this is 8. You guys will see. There's my right angle. And then this triangle is my helper triangle. You guys all see my helper triangle. Okay, very good. I'm going to erase my helper triangle. Oops, I erased his nose. Okay. And then I erase this guy here, this guy. Okay, and then so you're seeing all the points, and what I want to start doing is showing you like there's supposed to be like a circle that goes this way. Do you see all my circle points now? Do you see my circles? This is really see they're like circling up there. So that's what it's doing. Okay, let's continue on. It says reflect the lizard about the given line y equals to 1/2 x plus 16. So you're going to reflect it across this mirror guy right here. This is a mirror and you want to reflect him across. Okay. So now he's like facing the other way, right? So the way we do this is, I think the easiest. Okay. So first of all, I look at this and so it's almost like you want to go that same distance, right? So again, I'm probably going to use my arc marks and stuff like that. And this one's not going to be as exact because it does. So I want to let you know that your lizard now is facing the other way. So his little body is like this, right? And instead of him curling over to the right, now he's curling over to the left. Like, yeah, that's a horrible picture of my lizard, but you guys all see what I'm saying. And there's his little hands. And instead of his tail going up and around, now it goes like this. You guys all see it now? That's his tail. Okay, so regardless of, I'm not even going to attempt to draw that. You can go ahead and do that one. But that's what we're doing. So let's go through your takeaways. Let me go grab your takeaways. Okay, so I really like how the takeaways are in Desmo, so I'm just going to show you that. Okay, so we noticed, what we noticed about all three transformations, one of the things you should have noticed is that they retain their distance and angles, right? Like his nose didn't get skinnier because he got, translated, rotated, or reflected, right? So he maintains the same shape and size. He didn't get bigger because I rotated him. He just was the same. Um, and then, so therefore, they are congruent figures. Like those two lizards were congruent. So when you rotate, reflect, translate, you're not changing size. You're not changing shape. Um, so when we translated it, remember we connected all those lines? They move in the same direction and they move the same distance. For the rotations, all the points are on the same distance from the center and all points move through the same angle. So if you remember when we were looking at this, let me find him here, they all rotated 90 degrees, right? And then last but not least, for the reflections, all points are the same distance from the line of reflection and they're perpendicular. So because this line that we were, reflecting across, the slope was 1/2. So the slope of this is going to be 2/1, right? Because they are perpendicular. Okay. I just want to go through these with you. So two congruent figures are congruent if they are the same size and the same shape. Two geometric figures are defined to be congruent if there is a sequence of rigid motions that carries one to another. So the easiest way for me to describe this is if I handed you two pieces of paper and I said, hey, are these two papers congruent? Are these two rectangles congruent? Well, like, think about it. What would you do? Yeah, you'd line up, you'd like take the paper, stack them on top of each other, and tap them on the desk to see if the corners would match up, right? Okay. Let me see what's next. So an image is a picture. It's a visual representation of something. So that wasn't actually a lizard we were using. That was an image of a lizard. That's what they're saying. The orientation is determined by the order in which the figure's vertices are labeled. In the diagram, the vertices of the green pentagon are labeled from J to K to L to M to N in a clockwise direction. So orientation also has to do with the way it is sitting, right? So don't think that like some people, I'll just leave it like orientation. Like if I'm facing you and you're facing me, our orientation is different, right? Because we're facing in different directions. A pre-image is the original figure. Get it? Original figure. The image is the new figure created from the pre-image through a sequence of transformations. So the image that we made came from the pre-image. A reflection is a rigid transformation, isometry or isometry. I think I've heard professors say both. In a reflection, the pre-image and image points are the same distance from the line of reflection, and corresponding points is perpendicular to the line of reflection. So these lines are perpendicular to your line of reflection. That's why there's a little right angle mark right here. Okay, a couple more. Rigid transformation, also called isometry or isometry. The word rigid means that the pre-image and image are congruent, meaning you're not going to change the shape. You're not squeezing the Play-Doh as it moves from one place to another. It's congruent. The rigid transformation includes translation, meaning slides, rotation, meaning turns, and reflection, meaning flip. A rotation is a rigid transformation. In a rotation, all points remain the same, distance from the center of the rotation, move in the same direction, and through the same central angle. The orientation of the pre-image remains the same. Okay, last one. A translation is a rigid transformation. Okay, so you have their congruence. So this is the way I do it. I translate it up and over. right? It says each point moves in the same direction and the same distance. Okay, I hope this makes sense to you. This is just that beginning of the section of the unit where I'm going to have you guys try stuff. So go ahead and try the exit ticket and the ready, set, go, and we'll get into more of these transformations as we go through this unit. Thanks for listening.